Hello. Yes, we welcome you back to PSSB, and it is me, Richard, here. Yes, we are looking at this case today. It says briefly explain each of the following. The first one is this one. This is a compound which has two carbon atoms linked up together, and we need to take note of this. This compound has a halogen here and a halogen there. And the claim is that this compound has a lower boiling point than this one, which has one halogen. This is sometimes very confusing to learners because they know that halogen is polar, and the more the compound is polar, the higher is the boiling point. Then how do you explain a situation that this one has two polar atoms and it has a lower boiling point compared to the one which has one? What is the reason behind? The reason behind is from grade 11 work. We have to know that putting a chlorine atom on both atoms makes that molecule to be symmetrical. And when the molecule is symmetrical, it is nonpolar. So this molecule is nonpolar. And if it's nonpolar, what does it mean? It means that the intermolecular forces between it are weaker compared to this one, which is polar, because this one is non-symmetrical. And because of being non-symmetrical, it is polar. And what comes with polar are strong intermolecular forces, which leads to higher boiling point. So that is that. And after that, then you make the conclusion. What's the conclusion? That stronger intermolecular forces require large amount of heat to overcome. Yeah, that is that. So then comes this question. It says that this compound, it is propanol. It has a higher boiling point compared to ethanol. Why? Okay, the explanation here is that propanol has a bigger surface area compared to ethanol. And because of that, it has a bigger number of London forces compared to ethanol. I want you to take note that I'm talking about London forces, not hydrogen forces. Why? Because both of them are having hydrogen bonds. So what is making them different is the carbon chain, which is leading to bigger number of London forces. So that is that. And what do we do? Then we make the conclusion. What's the conclusion? Stronger intermolecular forces require a large amount of heat to overcome. So that is that. So comes this question, and it says that this compound here, let us see, 1, 2, 3, 4. It is 1 butanol. or butane-1-ol has a lower boiling point compared to ethanoic acid. Yeah, if you look at this one's bigger. We would expect it to have a higher boiling point compared to this one, but it's not. And what is the cause of that difference or that anomaly? Okay, we have to understand that both compounds have hydrogen bond. Alcohol are very polar molecules. Carboxylic acid are also polar. And so because of that strong polarity, both of them are having hydrogen bonds. So what is causing the difference? The cause of the difference is that alcohols have only one site for hydrogen bond between every two molecules, while carboxylic acid have two sites for attachment of hydrogen bond between every two molecules. Let's put that one down. We'll even show what we mean by that. So that is that. Butanol, one butanol has one site for hydrogen bond between every two molecules. This is what it means, that if you have this one as your alcohol, and what comes here is OH. Now you have to know that this one will go to the O of the other one. So what do we get here? CH2, 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 CH3. Yes, this is what we get. And this is one site only. This is not the case for carboxylic acid, as we are going to see. So there we are. We say that ethanoic acid has two sites for hydrogen bond between every two molecules. This is what we mean. What we mean is that if you have this and you have that and you have this is the carboxyl group. Then you have our alkyl group here. Then you have to know that what you call hydrogen bond is between hydrogen atom and another electronegative atom, but the hydrogen atom must be attached to a very electronegative atom. So what we are having here, we are going to have another ethanoic acid here. This time around, this one is inverted. It's O and H. So there is a hydrogen bond there. And this time, this side will have our O. And there is a hydrogen bond there. Remember, these are the hydrogen bonds we are talking about. So, what do we have here? A methyl group. So when you look at this molecule, these two pair, they are having two sites, while this one has only one site. And that's what causes this molecule or this compound here to have a higher boiling point. Because from the conclusion, what do we say? Stronger forces require a large amount of heat to overcome. So there we are. And with that, I would like to thank you for your time. The channel is PSSB, Physical Sciences Silver Bullet, and it is me, Richard, here. Yeah, don't forget to subscribe. Don't forget to like, to comment. We are simply the best. See you next time. Bye bye.